Welcome to my presentation. In this presentation, we shall see what an augmented matrix is and what a coefficient matrix is. So let me explain this with an example, and then I will explain what these terms mean and how we can write an augmented matrix and how we can write a coefficient matrix. A lot of times when we have a system of linear equations either in two variables or in three variables or in multiple variables, we should be able to write them out in terms of a matrix format. For example, let's say we have a system of linear equations of this kind: x minus 2y is equal to 7. That is equation number 1. And then let's say we have the second equation as negative 2x minus 3y is equal to negative 5. Let's say this is equation number 2. A system of linear equations of this type, which is in two variables x and y, can be written in a matrix format. When we write it in matrix format, we're going to take the coefficients. Let me write them down in these different steps so you can see. Step number 1, we take the coefficient of the x term, coefficient of the y term, and then write them out in this order. Coefficient of x here is 1. The ones are implied. We don't write this. We don't write them together, but we give it a little space here, and then next write the coefficient of y, which is equal to negative 2. And the constant number which we have on the other side of the equal to sign is 7. We write them out in that row, and then we come to the second, we look at the second equation and then pick up the coefficients of those x and y variable terms. The coefficient of x is negative 2. We'll write it just below the coefficient of x in the first equation, and the coefficient of y is negative 3. And the constant number on the other side of the equal to sign is negative 5. We put all of these in brackets like this, open close brackets like this, and we put a line here, vertical line, which is separating the terms on the other side of the equal to sign, 7 and negative 5 are on the other side of the equal to sign for equations 1 and 2. This is a matrix representation of this system of linear equations. When we represent it in this format, this type of a matrix is called an augmented matrix. This is called an augmented matrix. Okay, then looking at the same thing, we can also derive a coefficient matrix out of this. Since we said the coefficient, if we were to just pick the coefficients of x and y in equations 1 and 2 and then write them out in terms of a matrix, we already have that in this augmented matrix, and those are 1, negative 2. The coefficient of x in the first equation is 1. The coefficient of y in the first equation is negative 2. The coefficient of x in the second equation is negative 2, and the coefficient of y in the second equation is negative 3. We are not picking up the constant numbers on the other side of the equal to sign. If we were to just identify those, this alone is called the coefficient matrix. This alone is called the coefficient matrix. And that makes sense. Since we are representing only the coefficients, that is called the coefficient matrix. Since we are representing all the numbers in the system of linear equations, we call those as the augmented matrix. This is as far as representing the augmented matrix and the coefficient matrix. So this was with respect to an example where the variables were just two variables, x and y. What if we had an equation like this? Let me take another example here. In this example, let's say we have a system of linear equation of this type: 2x plus 3y plus z is equal to 2. Then we have 2x plus 3z is equal to negative 4. And then we have negative 3x plus y is equal to 5. Let's say this is equation number 1, this is equation number 2, this is equation number 3. This is a system of linear equations in 3 variables. So we can have system of linear equations in multiple variables, but here we'll gradually advance from understanding the concepts to solving problems in just a few minutes. In here, let us try to represent the augmented matrix and represent the coefficient matrix. As we mentioned in the previous example, we're going to pick up the coefficients of the variables x, y, and z in equations 1, 2, and 3, and then write them out inside the brackets, and that is going to be our augmented matrix. So the coefficient of x in the first equation is 2, the coefficient of y in the first equation is 3, and the coefficient of z in the first equation is 1. 1s are implied, and the constant number on the other side of the equal to sign is equal to 2. In the second equation, the coefficient of x is 2. There is no y, so the coefficient of y is 0. 0 times y is 0, so we can pick up the coefficient of y as equal to 0. And the coefficient of z is 3, and the constant number on the other side of the equal to sign is negative 4. And in the third equation, the coefficient of x is negative 3, the coefficient of y is 1, because 1y, so therefore the coefficient of y is 1. And since we don't have a z term, it is as good as saying it is 0 times z, or the coefficient of z is equal to 0, and the number on the other side of the equal to sign is equal to 5. So we picked up all the values, and therefore we're going to put a vertical line separating the constant numbers, and therefore this type of a matrix representation of this system of linear equations is called an augmented matrix. This is the augmented matrix. Okay. Then we can also represent, as step number 2, we can also represent a coefficient matrix from this, and if we were to just pick up the coefficients of x, y, and z in equations 1, 2, and 3, which we already have in this augmented matrix, we can then represent the coefficient matrix. So the coefficient matrix would be 2, 3, 1, 2, 0, 3, negative 3, 1, 0. And this is our coefficient matrix. This matrix is here without the constant numbers on the other side. This is called the coefficient matrix. This is the coefficient matrix. And we will use this augmented matrix and coefficient matrix to solve, to be able to solve simple example problems as we go. In my next presentation, we shall see more on augmented matrix and coefficient matrix.